This is Mech, a platform for robotics outreach education. We are living in an ever-increasing digital world where the ability to control technology is as important as the ability to read and write. We use the analogy, not everyone needs to be a chef, but they should know how to cook. Not everyone needs to be a professional programmer, but they should know how to control technology and write programs on their own. At the beginning of Mountaintop, we sent out surveys, and many middle school students reported being uncomfortable with programming, which leads us to our project. Mech Forward Robotics. Forward Robotics is an educational outreach program for middle school students aimed at teaching the fundamentals of working with sensors, data, and technology that will give students a platform to control and create with various types of hardware, like the spheros in this video. And we are going to be using Mech, the programming language, which was created by Professor Corey Montella. Our team sent surveys to middle schools and conducted interviews with school teachers and overall found this space in middle school where students lose interest in computing, typically when they transition from block layer scratch to real programming. Mech is designed to be a middle ground of these two extremes, and with Mech, Forward Robotics aims to finally make computing attainable for young students.
In addition to the surveys and interviews we've conducted this summer to gain a better understanding of the middle school technology education space, we've spent a great deal of time performing literature reviews and analyzing similar programs to what we envision for Forward Robotics. One of the main things we discovered is the overemphasis many middle school outreach programs put on algorithms and programming. In looking at the Computer Science Teachers Association standards alignment of the curriculums in FIRST Robotics and Code.org, we found that the majority of lessons focus on algorithms and programming and lack emphasis in other essential areas such as the impacts of computing. Although strong programming skills are fundamental to aspiring computer scientists, it is unnecessary for all students to have an in-depth understanding of them. As we've said before, we are not trying to create the next generation of chefs, but ensure all students know how to cook. We are aiming to develop a more balanced curriculum and teach students fundamental technology skills that they can carry with them beyond Forward Robotics. We have also studied the works of Brett Victor, a well-respected computer scientist known for his talks on the future of technology. We aim to incorporate his dynamic learning ideology into the development of our curriculum activities. Based on his work as well as the work of Alan Kay and Chris Granger, we have designed 4 initial activities for our Forward Robotics curriculum that we are in the process of developing. A dance activity to get students dynamically learning in a way that appeals to those who may not traditionally be interested in technology. A maze activity to enhance problem solving and teamwork skills. A tag activity to help students decompose tasks into smaller processes. And a bowling activity to allow students to interact with physical mediums using technology. In order to implement these activities, we have begun utilizing OpenCV for body tracking and color segmentation. Color segmentation is the concept of recognizing objects in an image or video based on the color of the pixels in the frame. In this example, we trace the frame pixels corresponding to the purple stripe on the sphero and replace them with the background pixels. Eventually, we hope to use this technology to track multiple spheros of different colors as they move across the ground for our tag and maze activities.
Here you can see OpenCV tracking a body using different focal points and then connecting the dots to create a rough sketch of a body. This can be used by attributing the position of the body to the direction of the sphero robot, allowing it to curve around cones and knock down the pins.
As for our future goals, we'd like to continue to connect with local educators to get feedback on our program during the developer process so that we can improve upon it before the release. And we would also like to implement the Mech libraries that are needed for activity functionality. As for our long-term goals, we'd like to run the outreach program in local middle schools like Berkeley. Then we would like to potentially make the program available for teachers to be able to implement it themselves in their classrooms. And then last but not least, we would like to write and publish a paper on our findings.